Hi everyone, this is Hassan. Today for my presentation, I have chosen a topic on GMDSS. I have named it A Brief History on Development of GMDSS. I will try to put an effort to say something on this topic. So let's begin our journey into the evolution of GMDSS and see how it has transformed the safety of seafarers across the globe. The full implementation of GMDSS on 1st February 1999 was really a milestone in maritime history, making almost exactly 100 years since the first recorded use of wireless technology to aid a ship in distress. This system has since become an essential component in ensuring that no vessel in distress is left unhurt and that lives at sea can be saved more efficiently. But how did we get here? How did maritime distress communication evolve from Morse code to the advanced satellite-based network we rely on today? In this presentation, I will take you through the history and development of GMDSS from the early days of wireless communication pioneered by Marconi to game-changing adoption of satellites in maritime rescue operation, and finally to the modern and future advancement of the system. So, before going further, let's see what GMDSS is exactly. What does it mean? As we as we know, GMDSS stands for Global Maritime Distress and Safety System. So basically, it is a system agreed internationally, designed to ensure that no ship in distress goes unhurt. Unlike the old manual distress methods, this system is automated, capable of sending out distress alerts by radio and satellite networks, even if the crew is unable to do so manually. Before GMDSS, distress call depend on radio operators listening for SOS messages, which meant there was always risk of human error or missed signal. But with GMDSS, emergency alerts are automated and can reach global rescue organization instantly, improving response time and saving lives at sea. Throughout this presentation, we will explore how this revolutionary system developed and how it continues to evolve to enhance maritime safety worldwide. So the next question comes, why we require GMDSS? What was the need that developed GMDSS? As we know, before GMDSS era, before 1990, that pre-GMDSS era, ships relied on traditional distress methods such as Morse code and visual signals. But those methods had serious limitation, as we know, because they required human intervention and also they have a limited range and often went unnoticed during emergencies. So, for that reason, we need a faster, automated, and globally distress system, and it became evident with maritime disasters of Titanic, where inadequate communication played a role, and we have lost over 1,500 lives, and that was a huge blow to the history of mankind. So, with GMDSS, we have now a fail-proof way to send distress alert to the casualty ship, ensuring that help reaches them as quickly as possible. This system marks a significant step forward in maritime safety, minimizing the risks of distress calls going unanswered. Now the time to pay our tribute to the father of wireless communication, the great Italian scientist Marconi, who invented radio in 1895 and successfully transmitted first wireless signal. The journey of GMDSS began from that day, over a century ago. After 4 years, on 3rd March 1899, a freighter collided with the East Goodwin lightship in the English Channel, and first wireless distress call was sent to the South Foreland Shore Station, marking a historic moment in maritime safety. This incident demonstrated the potential of wireless technology to save lives at sea, laying the foundation for a modern maritime communication system. Let's have a glance on pre-GMDSS era. That time, the industry had the advancement of wireless radio, yet they had significant limitations. Like before the 20th century, ships only relied on flag signaling and distress flares. In early 90s, Morse code via radio telegraphy became standard. The Titanic disaster in 1912, it exposed the need for the better distress communication. These challenges of those earlier days led introduction of global maritime safety regulations, which paved the way for the modern GMDSS. But in maritime industry, we cannot introduce a system without approval by the regulation and convention. So the question is, what regulation and convention adopted and implemented GMDSS? The answer is the Solas Convention. The Titanic disaster was a wake-up call for maritime safety regulations, leading to the development of Solas Convention. In 1914, the Safety of Life at Sea Convention was adopted. That was the uh, initial version, the first version of SOLAS. Then, in 1927, the International Radio Consultative Committee (CCIR) was introduced. And in between 1950 and 1970, maritime radio distress frequencies are standardized. So, SOLAS played a crucial role in improving maritime communication, eventually integrating GMDSS into its framework. Now, we have our modern GMDSS system, but we cannot stop here. We are looking for more safety at sea because still there are some limitations like human errors which we cannot overcome easily. So the modern GMDSS is shifting towards automation. A small timeline is here. By the 1960, it was clear that automation and satellite technology could revolutionize maritime safety. In 1960, IMO recognized satellites' role in search and rescue. 1976, Inmarsat has been established for emergency maritime communications. 1979, IMO began work on GMDSS, and in 1988, GMDSS was officially adopted as a part of SOLAS amendments. This shift marked the beginning of a new era in maritime distress communication. So the next thing is what piece of equipment or technology make up this modern GMDSS? Let's talk about this. We have our modern satellite system consists of Inmarsat, Cospersat, Iridium, MEO satellites, LEO satellites, and many more. We are using radio communication through VHF, MFHF with digital selective calling to alert the distress unit. We have EPIRB and third, to indicate the position of distress. Beside this, there are a few supporting equipments to enhance GMDSS communications. These technologies ensure that no ship in distress is left unhurt, significantly improving search and rescue operations. Let's talk about how GMDSS is implemented and adopted. As we know, the full implementation of GMDSS took place on February 1st, 1999, which was a major milestone in maritime history. But it started in 1992 with initial implementation phase. Then in 1999, full adoption took place after almost 100 years, the first wireless distress transmission. GMDSS has great impact with faster response time, globally standardization, and improved safety. GMDSS has since become an essential component of maritime safety worldwide. We discussed the past of GMDSS equipment. These are the modern GMDSS equipment we are using nowadays. With this equipment with the integrated system ensuring globally coverage. These are the mandatory equipments on board to coordinate with international search and rescue operation. Okay, let's talk about the challenges and limitations of modern GMDSS equipments. We are having our best of the best technologies and equipment, but still we have limitations like equipment failure because of poor maintenance, false alert, sending false alert, and misuse of equipment, and most important, the cyber security threat. But the hope is the international parties are working together day and night to overcome this limitation by providing crew training, making risk assessments, network segmentation, encryption and authentication of data, as well as implementing incident response plan. Ladies and gentlemen, we covered the past and the present of GMDSS. The picture is showing now the future of our GMDSS equipment. We can expect the future GMDSS will be equipped with next generation satellites with AI and automation in distress recognition with potential integration of 5G network. This might be an perfect example how a future automation ship would be. A brief feature of an automation ship with highly integrated technology, which we are expecting to come in future. It's already come. And this would be the autonomous networking system where the satellite will play the key role. Here, finally, this might be the future design of our beloved lady. Might be or might not. We are not sure. But we can say if this comes, we have to think of our job. That's all from my presentation, ladies and gentlemen. Thank you all. Thank you for your kind patience.